So this is my vintage rotary cell phone project, which is taking an old rotary phone and turning it into a Nerves-based cell phone. What you will learn, a very deep dive into a Nerves project, learn how a rotary phone works, a little about GPIO, a bit about Gen servers, and a little bit about doing a finite state machine using GenState Machine, which is the core of the application. I better start with how a rotary phone works. So I don't think I'm going to be able to do a live demo. I was going to do a reveal of the phone. But here's how a rotary phone works. You pick up the handset. You dial numbers like this, and then the phone will make the phone call. You can talk to them and hang up. Just in case some of you never experienced rotary phones. How it started. It started with a project on Adafruit that was a Star Trek communicator. It was a 3D printed communicator with a phone modem. So I messed with that project for a while, got a phone to work, and then at some point I got inspired to try and turn a rotary phone into a working cell phone. Here was the original project. So the goals. Just explain how a rotary phone works. So basically, I wanted to go for having the phone work just like an old rotary phone on a landline would work. You should be able to lift the handset and dial. By the way, this is where the term dialing comes from, because there was a dial you had to use. It should ring when there's an incoming call, which you can pick up by lifting the handset. And I also wanted to have this run on battery power, and I modified the cord to put a USB end on it, so you can actually, just plug the thing into USB, and ideally it'll just work and keep charging, or you can just pick up the phone and walk around with it. Some features from Nerves. The software is updatable over the air, so I do code pushes while it's looking in this state, not opened up and hooked into to a USB. I can monitor the code with SSH, and the phone automatically has 99 and 0.99s of uptime because it's Erlang based. Okay, that's not true. It's down right now. And I do want to do a live book for this at some point. Oh boy, here's some parts. So here we have a Raspberry Pi Zero W, which is the core of the this is the brains of the operation. I got this WaveShare 4G cellular modem, which is in the form of a hat. So this just pushes down onto the pins of the Pi. A battery, standard fare. At some point I decided I really wanted to have a bell, so I have I got this trembler bell, and then I have this charger that sits inside the phone, and to power the bell I need a little more extra juice, so I have this bigger battery here, and then here is a little this is an Adafruit Perma Proto board, and it's kind of a half step between doing breadboarding and real permanent circuit board. Well, I guess this is probably going to be just permanent. So this is a circuit for ringing the bell. So the power comes in here. The Raspberry Pi controls GPIO here, and this is the output to the bell. And then this is just a harness that goes to the phone for the dialer and ringer. Ended up having to design a custom case for this to fit all those parts, which was one of the bigger challenges. But we're not going down that rabbit hole. And printed with a Prusa. Here's the Prusa slicer. Again, going to skip this rabbit hole. So here's what I've ended up with. This is the base of the phone. Cut up some yoga mat material to kind of flatten it out and also to insulate it. And then here's the case. So here's I made a little pocket for the battery to slip under, and then I made this for the circuit board to slide in. And here it is with the Pi. So I made little pegs for it to slide on, so it's not too permanent, but it holds well enough while I'm working on it. Oh yeah, a little retro talk. So when you say a phone is on hook, on or off hook, there was a hook on the side of the phone, the old-timey phones. So you hung the earpiece on the hook, and that would hang it up. So here's a little more detail on the custom circuitry. So this is just a MOSFET. Basically, all this does is when it gets a high signal on one pin, it'll let the high voltage flow through to the bell, and that's isolated from the Pi. Then this is just a way that I could have sort of a set wire harness that's connected to the phone that plugs in here, so I don't have like separate loose pins. And then at one point I added a NeoPixel LED that I was going to use for status, so I can change the colors depending on what's happening with the phone. Here it is with the modem on top. So inside there's just 3 connections. So I sort of converted the headset of the old phone to use a jack. So I can just plug, so that the jack goes to the old-timey earpiece or headset, and plugs in here. And then over here, this goes to the USB charger. And in here is the wire harness that connects to the hook and the dial wires. So basically, all I'm doing with the hook and the wire is I put 5 volts in one end and see what comes back. If the phone's on hook, it'll be 5 volts. If it's off hook, no volts. And here's the full house with the battery and everything. So, moving on to the software, built with Elixir and Nerves. Nerves is the platform for embedded systems for Elixir, but you're all here, so you probably knew that. Gen servers. I use a lot of gen servers, and I'm going to go into detail about that. GenState Machine. This is really the core of the application that I'll get into. GPIO for reading the wire clicks. Circuits UART to talk to the phone, which uses AT commands. The structure of the code. So at the heart of this is the finite state machine. With this state machine, you can only be in one state at a time. So I thought of this analogy with a gear shifter. Whatever gear you're in is in the state, is the state that you're in. And it's finite. You can't just, it's got a fixed number of states that you can be in. And here they are. The phone can be on hook. It could be off hook, waiting for a digit. It can be on a call. It can have an incoming ring. Or it can be on hook sleep mode, which I haven't actually implemented, but to conserve battery, I'm adding that. Gen servers as worker bees. So this is a hat tip to the book, Designing Elixir Systems with OTP. They mentioned worker bees, and I'm kind of expanding on that idea to think of as processes, as worker bees, which also applies to gen servers. A gen server is if a process is pretty plain, lightweight, handles messaging, a gen server offers it's more convenient programmable features for developers. So it's like a process that's all dressed up. Gen servers and processes like worker bees are alive, except when they're not, but we're not going to talk about that. They are a basic building block of Erlang and Elixir. Each process has its own memory space, garbage collection. They run independently. They share nothing. Processes are where code runs in the Erlang VM. Processes and gen servers can listen for and respond to messages. So typically a process is either doing something, waiting for a message, or waiting for a timer to go off so it can do something. In my humble opinion, processes are one of the best features of Erlang and Elixir. And for comparison, you can have like an object in another language, but is it running? What's giving it life? Is it riding the lightning of a thread? I'm not sure. So yeah, processes. So I'll start with the hook gen server. Circuits.gpio, the hook server registers with GPIO to say, hey, tell me about changes in the hook pin. So when that happens, if there's, say, a change, like the phone goes on hook, a function call is triggered, and it sends the gen server basically a message saying, hey, here's a 1. That means I'm on hook. So it's real ones and zeros stuff at this level. So yeah, depending on the hook status, you'll get different messages from circuits.gpio to the hook server. And now the hook server is going to say, okay, well, what does that mean? Maybe it gets a bunch of clicks and it debounces some of them. And ultimately it's going to tell the finite state machine, which is called cell state machine, What's going on? We went on hook, we went off hook. That's it. 2 messages. Now the rotary dial Gen Server, again, it's based on circuits GPIO. So in this example, a 3 is dialed. So we'll have a corresponding number of the way a rotary dial phone works is it's going to generate, if you dial a 3, it's going to generate 3 clicks within a certain amount of timing. So circuits GPIO sees that as a bunch of clicks and just fires that off in function calls. Then it's the job of the Gen server to figure out what the clicks mean, to figure out the timing, remove any noise, debouncing, whatever it has to do, and then it needs to decide, okay, a 3 was dialed. And then we have the Modem Gen Server. So this guy controls the WaveShare modem, and it does that by sending AT commands. I'm sure some of you are familiar, but basically you can say ATD and ATD and a phone number, and it'll make a call. ATA to answer, etc. So for the most part, this server is responsible for, well, here's all it's responsible for. It can make a call, it can hang up, it can answer an incoming call, and it can play a tone. This is, I think, the only input-output Gen server. It can also notify the CellState machine when a call is coming in. The Bell server. This server is pretty simple. You just call it and tell it to ring or to stop ringing, and it rings the bell. Putting it all together, so here's the whole system. You know, the phone goes on or off hook, some numbers get dialed, and these messages are sent to the CellState machine. These servers are not aware of each other, only the central command here. So yeah, they'll, you know, if a call is incoming from the modem server, then the CellState machine will ring the bell. And you know, when making a call or hanging up a call or whatever, the queen bee here sends commands to the Modem Gen server, which controls the modem. I'm going to go a little deeper into the GenState Machine. Oops. So the GenState Machine handles events and changes states in a way that is explicit and constrained. You can allow only what makes sense for the app to do. For example, if you're on hook and you get an on hook message, it doesn't really make sense. You're already on hook. So let's see. How this is implemented, I think, is one of the coolest things I'm going to talk about. Yeah, because this is just a fun programming paradigm. So let's say we are currently on hook, and we got an off hook message. This is how it's going to be handled. So you just declare the name of your state as the function name, and you return when you want to change a state, you just return an atom with a state. And if you have and if you want to track a go off hook event, that's here. So the cool thing is you can just make up these names and it'll just work. So I'll go into that a little more here. So when the phone's on the hook, you can go off hook and it'll change the state to off hook dial tone. So this is a catch-all. This is getting in something unexpected. And here, if the phone is on hook and starts ringing, then we're going to ring the bell and change the state to incoming ring. And if it stops ringing, we're just, I guess, not going to do anything. So if we're off hook, waiting for digits, and we get a digit dialed message with a digit, then it's going to, and this is a little bit of pseudocode. I've removed some of the code, but if it's collected 10 digits, it's going to move on to making the call. Otherwise, it's just going to keep collecting digits and adding to the state. And if we're off hook collecting digits and we go on hook, then we change the state to on hook. If we, and this is a default behavior. And I think this is the last one of these. So if we're on a call, an active voice call, and you go on hook, we're back to on hook. Here's another sort of catch-all. And here, if we're on a call and there's an incoming ring, that doesn't really make sense. So it should probably just block that, or maybe we're going to implement call waiting, and you can hang up the phone and pick up another call. That's most of the meat of the story there. Some tips for working on Nerves projects. I do feel like it's kind of a golden age for IoT. There's a lot of cool companies and a lot of like cool stuff you can buy. You can buy sensors for just about anything. So good times. Here are some of my favorite brands. Adafruit I use a lot. SparkFun is cool. DigiKey, Mouser, and Oshpark. Keep a journal of your progress. I have like just a text file that I just put the next thing I want to work on and whatever I did for a given date. And that's my super simple project process. Get two of everything. You want to have, in my case, get about 7 or 8 of everything because I'm gonna fry them or something. But you always want to have a spare that you can swap out and see, oh, is the problem a modem or, or something else like software. The Nerves channel is great. Very welcoming. Check it out. I dove into some KiCad during this project. Found the KiCad Discord was a good place for hardware questions. Here's an important one if you do battery powered stuff. So this is, this project uses batteries. I've gotten burned by making an order from Adafruit, which is East Coast, and I'm West Coast. And if you add in LiPo batteries, it changes your shipping options. So the first time I did this, I was like, oh, let me just grab an Amazon battery and not affect my shipping options. So the problem is some of the batteries you'll find, some of the batteries, cables, etc., that you'll find like on Amazon are meant for remote control vehicles, and the polarity may be backwards. The batteries may not be as good, so watch out for that. And the obligatory USB gadget mode. If you're going to use gadget mode with a USB cable, you want to make sure the cable has data and it's not just charge only. This will burn you at least once. I started labeling my charge only cables. I branded them with a sticker so I won't use them by mistake. And since then, I've mostly been using Wi-Fi for remote access anyway. So I haven't been using gadget mode so much. The results. The phone, so it mostly works. Its biggest issue is stability. So you can pick up the phone, dial, have the call go through. The voice quality is acceptable, if not great. And I do have the cord that's turned into a USB charger. Room for improvement, stability. It's not quite there, and this is something that's plagued me throughout the whole project. It's mostly just that in trying to squeeze everything into a small space, there's just a lot of wires moving around, getting crunched. I've torn the leads from batteries just because I'm trying to see if they'll, just by handling it so much, just trying to fit things. And the bell ringer battery is a separate battery that's not on the recharge circuit. So I can't just pack up the phone and leave it. I still need to be able to swap out that battery. So all the functional goals have been met. Like things work, just not super stable. What's next? The monophone. I don't know if I mentioned, but this is a 1930s era monophone by Automatic Electric. So better stability. I really need to have the circuitry reviewed and see what I can improve on there. And along those lines, see if I can get a charge system that handles power for both the phone and the bell ringer. I do want to do a live book on this. Other potential projects. Anything you can do if you can control a cellular modem, anything you can come up with, you could do. SMS server, hat tip to Alex for this suggestion. You could have the modem interpret incoming SMS calls and do things. You can have it spam phone calls. You may have won a cruise. Give me your credit card number. But no, you shouldn't do that. Nothing malevolent, please. Hey, write an app to call into DirecTV for you, and you can put them on hold and make them press keys. Whatever you can think of. And that's it.
All right, thank you, Brian. I've got it here so everyone can unmute if you have a question to ask.
Hey, Brian. Great presentation. You mentioned that you have the cord going to the landline for charging. Do you have an RJ11 so you can plug into a landline and get the power from the phone company, the lines that are coming in, and use that to charge?
No, but you're giving me ideas.
Yeah, because I know there's a voltage there for for being able to ring the phone.
Yeah.
So I was wondering if that might be that'd be kind of cool that it plugs into the RG11 jack.
Yeah, that would be nice if that could work. I know the voltage for ringing the phone is really high. I know because I've held on to bare wires of when an incoming call comes in, and you can definitely feel that. But
You might have to ring your phone all the time in order to charge it. Like call it.
right, that could work. But yeah, what I did is this is still the original cord, but it now has a USB on the end of it, if you can see that. Yeah, and these old-timey cords are funny because there's actually fabric as insulator, not rubber.
It's really cool, Brian. Thanks for presenting. I have a challenge for you, though. You can make it super vintage by adding an old tape recorder and doing a tape-based answering system with this.
That could work. That could work.
Hi, Brian. Hey, awesome talk. It was really nice to see all the work and effort you've put in there. I do have two questions only. I have a lot of questions, but I'm gonna reduce it just one.
Please.
Just two. So first of all, is this a commercial project that you're building to sell or to make money, or is it like an open source thing that you're gonna be posting somewhere with code and stuff that people can look at?
Good question. So it's not commercial. Gridpoint where I worked, it wasn't interested. No, I'm kidding. But no, it's not commercial. It was just a fun thing that just kind of grew and grew. When I started out, it was a lot simpler, but that's a whole other rabbit hole. So would I open source it? Sure. Yeah, if there's interest, I would release the code. And yeah, I was thinking if somebody really wanted to do it, I have the I have the 3D model for the parts for the monophone, so I could release that as well.
Yeah. I think you've got some interesting things in your. Well, it seems that you've got some interesting things in your code because the state machine and the kind of problem that you're using state machines to solve, it's pretty good to education. So teaching people to write code and to think and to develop solutions, this type of code is very good for education. I have worked as a mentor in the past, so I would love to use it. And the other question was, and now it's more about the project itself. Well, this is a Rotary phone, but at the core, this is a real Raspberry Pi with a lot of power and stuff like that. So I thought that you could be doing interesting stuff, for instance, to record calls and record data, and perhaps even share this data with a real smartphone app or something like that, and perhaps doing the two-way sync and stuff like that. It might be a cool next stage for this project, perhaps.
So what did you have in mind for a project?
I was going to ask a question, and I ended up doing a suggestion. But the idea is to use the capabilities of the Raspberry Pi to record data, like record local data, either by like storing on SQLite or some CDRT or something like that, and do a two-way sync with a server and perhaps reading it in a smartphone app. That would be awesome. Like call recording is a really cool stuff, and perhaps it might be a cool next stage for your project. And I think that the question was more like, have you thought about this? Do you have plans for it?
No,
Yeah.
this is pretty much, I think, as far as I have in mind to take the project. My yeah, my original inspiration was just to have this phone sitting on a desk or sitting somewhere and just working.
This is awesome project.
Thank you.
I was wondering, you had mentioned that the system had some issues with stability. Is it like I did some prior projects where I was using a Pi Zero, and then I upgraded to like uh, just a regular Pi, and that solved a lot of my problems. And I think what was happening is it just couldn't handle enough current for all the I/O that I was doing. Do you think that's possibly it, or do you think there may be some mismatches? I noticed you had like a transistor that was running the bell. Like, is there maybe some resistor with the like? Do you think it's a power thing, I guess, or do you think it's more like on the software?
I think it doesn't look like it's software because I can get on the SSH into the device and see what's going on. I think, but there definitely could be issues with power, issues with the circuitry. I do want to have somebody, I do want to draw up a schematic of what I've got and show it to somebody and see if I can do a little better. I think the biggest instability I've run into is just like the space is tight. And here's another rabbit hole, but I started with a different phone that was super spacious. So I think a lot of it is just and I've kind of upgraded the connections. Like I have, all the wires are flexible. Not sure if I've got this handy. Good, I do. So I started off with something like this, where these were my wires. So this is pretty hard to use. So yeah, a lot of it is just, I've got little wires going into pins and then hopefully it fits and you don't crunch down on the wires and electronics when you close the thing. But that's most of it. Like just before the charging is another issue. It seems like it's just not holding a charge too well, like it's draining too fast. And it's been hard to figure out how stable it is because I keep iterating on the the parts inside and the 3D printed stuff, just trying to get it to fit better. So yeah, I think the main source of instability is just like wiring and moving things. Ben.
I would like to say yes, please open source this. I am definitely interested in taking a look at this. But also I was wondering, can you go back to where you were talking about the all the different gen servers you had? It was fairly near the start, I feel like. I forget if you had like a diagram that showed them all off or something.
Yeah, this one?
Yeah. So, and I'm not 100% sure. Maybe like there's something I didn't quite pick up on. So these individual gen servers, the state machine itself is only ever talking to one of them at a time, question mark?
It is it has callbacks for let's see, let me think about that. Is it only speaking to one at any time? So this on-hook call, for example, would be calling from the hook gen server, but there's nothing like it'll process whatever functions get called in order, and then the state may change, and then it'll process the next message. So yeah, I guess it's just pulling messages off the message queue.
Hmm. Okay. I'm not 100% sure where I was going with this question. I think it was something about consolidating the individual gen servers to just be a part of the state machine, but I think I lost my train of thought somewhere. I'll keep thinking about it though.
So I like having these separate gen servers that just do they all just have one job. Even the cell state machine. So that rather than having to figure out, I mean, you could go the other direction. You could say, okay, the cell state machine is going to do everything. But then, you would just be processing callbacks for each of the things that are separate in one thing. So I like having it sort of separated and more manageable in manageable pieces.
Yeah, no, yeah, that totally makes sense. I was just like, I didn't entirely remember like all of the specific gen servers and all of their purposes, and I was like, I wonder.
It's like there's a question in the chat, Brian, and the gist of this one is I've been looking at something like this to replace a mobile phone with a landline phone at home to keep family members. I think it's basically safe from radiation and EMI, and being able to put the receiver and antenna away from the phone. Could this work for that type of purpose?
Let's see. So you'd want to keep the receiver away. Yeah, I guess you could. I guess you could just run with a long, basically a long phone cord, like a long headset cord, and keep the other electronics away. And you could, I mean, the hook is just basically a switch, so you could run a switch across some line as well, like just a long wire, basically a long cord. Yeah, I guess you could do that.
Hi, Brian. Thanks. This is great. Gives me some ideas. I think I missed it, but the original handset for this old phone, you were able to interface that to the cell modem?
Good question. So that this handset has the original speaker in it, and this good old fashioned speaker, and that just worked like a charm. I tried using the original carbon microphone, which I had mixed success with. And I got some advice about it that you need to put some voltage through it, in order to get it to work properly. So I don't know. At some point, I kind of bailed on that rabbit hole, and I actually soldered a modern Electret microphone in there.
Okay, cool. Thank you.
Sure.
I actually worked on a very similar, but much less ambitious project myself a year or so ago, where I built a 4-line switch essentially for 4 rotary dial phones, but it doesn't have any kind of connectivity with the outside world. So basically, I've got 4 phones in my house that can call each other. But I was starting to look into maybe integrating like voice over IP or something, and I'm curious how the audio signal gets from the cell modem to the phone. Does it actually go through the Raspberry Pi, or is it a direct connection?
No, it's just a straight the WaveShare modem has a straight audio jack that I plug into.
Gotcha. I see.
And then I turned the handset into turned the end of the handset into a I added a jack or a plug so that I can plug in.
I see. Okay.
I can just swap it out with a especially for testing, I can just swap it out with a regular jack and it works.
All right, cool. Great. Thanks very much.
Sure.
It's a really neat project.
Thank you. Looks like that's it.
Yeah, I think everyone's out of questions. Well, Bryan, thank you very much for this, and good luck at the ElixirConf talk. This looks like it's going to be great.